Hi, geometry students. I wanted to make a quick example to go along with the back to school review notes and example sheet. So I'm not going to do all of them, but there was just a few that I thought it might help to see them like broken down versus just reading through them. So the first one was the idea of simplifying radicals and how to tackle that. So for that first example that they give you where it's radical 48, what I want you to remember when you think about that list of perfect squares, you're trying to find the largest factor of 48 that is a perfect square. So in this case, it would be 16 and 3. So how I want you to think of it is you're going to break this into radical 16 times radical 3. So always the perfect square and then whatever's the leftover. The one that's the perfect square, take the square root of it. So square root of 16 is 4. And then you're left with the radical 3. That's it. That's as much as you'd have to do. Right? Sometimes people will try to take the square root again, but remember, once you've taken the square root, the little radical hat comes off, you are done. Extending on that same type of question, now if you're doing operations, let me slide this way with radicals, you have to have the same radicand first, or the same number underneath the radical to be able to do it. So you can't just add 48, 27, and then subtract 18. Instead, you have to simplify, 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 and then look to see if you can combine. So since we just did that one, we know that's going to be 4 radical 3. For this would be square root of 9 times the square root of 3, or 3 radical 3. Here, this would be the square root of 9, and then times the square root of 2. So that would simplify down to 3 radical 2. All right, if I bring everything down, we have 4 radical 3 plus 3 radical 3 minus 3 radical 2. The ones that both have the radical 3 attached, those are considered like terms, so we can combine them. So we've got 4 radical 3's here, 3 more of them there, so we have a total of 7 radical 3's. And then we can't combine it with the radical 2 term, so we just keep it as is. So then minus 3 radical 2. That would be as far as you could go and leave it in exact form or simplest radical form. All right, the other one I wanted to look at with you was on the next page, a little factoring practice. So it's the one that starts with x squared equals 18x minus 32. If you are trying to solve a quadratic equation, just meaning an equation that has an x squared in it, you need to get everything on the same side first. So that's what I mean by one side equal to 0. So in this case, we can subtract over the 18x, add over the 32, so that it's equal to 0. And then the factoring, you guys might remember this is the add multiply, trinomial factoring, reverse box factoring. There's lots of ways to think of it, but factors of 32 that add up to 18 would be 16 and 2, both of them being negative so that they multiply to give us that positive here. And then you can build a wall between it, take each factor, set it equal to 0, add it on over, we get 16, add this one over, we get 2. If you're feeling fancy, you can throw some curly brackets on there. Otherwise, just box it in and call it a day. Last one I wanted to go through in this little video was the ones using Pythagorean theorem on that last page. So a squared plus b squared equals c squared is only true when you have a nice right triangle there. So the two examples that follow are both right triangles. The first one, if you look, the two legs are 2 and 6. The side opposite the 90, which is the hypotenuse, that's the x. So here's my a and b, which are interchangeable. So we would have 2 squared plus 6 squared equals x squared, as we would plug it in, and then we can go from there. So this would give us 4 and 36. I picked this one in particular because we get 40. If this was a perfect square, we would just take the square root of it and call it a day. Because it's not, we are going to simplify it. So the biggest perfect square that goes into 40 is 4, and then times the leftover of 10, and then the square root of 4 would be 2, and then we keep the radical 10 here. The only time we wouldn't do this is if the direction said, round to the nearest tenth or something like that. In that case, we'd go right to our calculator and take the square root of 40. In the case of that second one, it does come out perfect. So you would get an answer that's just plain old 8. Right? So you will sometimes get nice whole numbers, just not all the time. All right. I hope those helped. Have a good one.